In today's lesson, we are going to be dealing with polynomials. A polynomial is an expression that is made of multiple terms. In this case, each of these are our terms. And a term is going to be made up of a coefficient multiplied by a variable that is raised to a power. And in the case of polynomials, the power that our variable is raised to has to be a non-negative integer power. So in this case, our coefficient is 3, our variable is x, and it's raised to the power of 2. Over here, our coefficient is 2, our variable is x, and it's raised to the power of 1. Now you might be wondering how this 5 by itself is considered a term when it doesn't look like it is a coefficient multiplied by a variable that's raised to a power. But we can write this 5 simply as 5x raised to the power of 0. And we know that anything raised to the power of 0 is simply 1. So this would be 5 multiplied by 1, which is simply just 5. So another way of writing down 5 is 5x to the power of 0. And this doesn't have to be x, this can be any variable, and you would still get the same answer. So indeed, this by itself is still considered a term. Now we call this a polynomial because we have an expression with multiple terms. And more specifically, this is known as a trinomial because it is composed of 3 terms. We can have a binomial, and a binomial would be composed of 2 terms. So let's say we have 2x plus 5. Here is our first term, and here is our second term. So this would be a binomial. And similarly, we can have, let's say we have just the 5 by itself. This is considered a monomial because it has a single term. Now, when dealing with polynomials, you might have a question that asks you to identify the degree of a term or the degree of an entire polynomial. So the degree of a term is simply the power that our variable is raised to. So let's say we're dealing with this term right here. The degree of this term would be a second degree term because our variable is raised to the power of 2. When we're asked what the degree of an entire polynomial is, so let's say we're asked the degree of this entire expression here, that is simply going to be the degree of your highest degree term. So because this is our highest degree term, since our variable is raised to the highest power in this term, this entire polynomial is also going to be a second degree polynomial. Let me give you one more example just to make that even more clear. Let's say we had the following expression. This is also a polynomial. And let's say you were asked what the degree of this term was. The degree of this term is a second degree term because our variable is raised to the power of 2. But if you were asked what the degree of the entire polynomial was, it would be considered a third degree polynomial because the degree of our highest degree term is a third degree term. And this is our highest degree term since our variable is raised to the power of 3, and that's higher than 2 or 1, or in this case, 0. Usually when we're writing down a polynomial, we're going to write down our leading term, which is going to be your term that has the highest degree term first. And you're going to do it in decreasing order. So the way I've written it down here, we have our highest degree term first, followed by our second highest degree term, third highest, and so on. Now let's look at some examples of multiplying monomials, binomials, and trinomials. So let's say we have this monomial here, 2, and we're multiplying that by a trinomial, 2x, let's say 2x squared plus 3x plus 5. This is a trinomial, it's made up of 3 terms, and we're multiplying it by a monomial, which has only 1 term. The way that we're going to do this is we're going to multiply our term outside of the brackets, one by every single term inside the brackets. So let's start with our first term here. 2 multiplied by 2x squared. We're going to do 2 times 2, which is 4, and our x squared here. So that's 4x squared. Now we're going to multiply our 2 by 3x. So 2 times 3 is 6x, since we have our x here. Now we're going to multiply our 2 by our last term, which is 5. And 2 times 5 is equal to 10. So when we're multiplying this monomial by this trinomial, that is the answer that we're going to get. Now let's try another example where we are multiplying a binomial by a trinomial. So we're going to use exactly the same logic that we did in this example here, except we're going to have another term to multiply. So we're going to start with our first term outside the brackets, multiplied by our first term in the brackets. 2 times 2 is equal to 4. X squared times x squared is going to be x to the power of 4. Now we're going to multiply our 2x squared by our second term. 2 times 1 is going to just be 2. And x squared times x is x cubed. Now we're going to multiply our 2x squared by our last term in the brackets. 2 times 3 is equal to 6. And we have our x squared here, so this is going to be 6x squared. Now we're going to do exactly the same thing, just with our second term outside the brackets. So we're going to multiply 3x by 2x squared. 3 times 2 is equal to 6. X times x squared is equal to x cubed. 3x times x is just going to be 3x squared, because we have 3 times 1 is 3, and x times x is x squared. Now we're going to multiply 3x by our last term in the brackets. 3 times 3 is equal to 9. And we have our x here, so this is just going to be 9x. And now we can simplify this, because as you can see, we have a few terms here that are raised to the same degree. We have x cubed and an x cubed here. We have an x squared and an x squared here. So we can actually add these together. We only have one that has x raised to the power of 4, so that's going to stay 4x to the 4. Now we have 2x cubed plus 6x cubed is going to be 8x cubed, because 6 plus 2 is 8. And we can, as we write these down, we can cross these out so that you don't get confused here. Now we have 6x squared and a 3x squared, so 6 plus 3 is going to be equal to 9. So we can write down 9x squared here. And then we're left with a 9x. And we can just double check to make sure that we've written this in decreasing order. So we have our highest degree, which is 4, and then 3, 2, and 1. So this is our final answer. Now I can give one more example. Let's say we have 2x squared plus 3x plus 1 multiplied by x squared plus 2x plus 3. Again, we're going to use the exact same logic that we did before. We're going to multiply each one of these terms by each one of these terms. So let's start. 2x squared times x squared is going to be 2x to the 4, because we have 2 multiplied by 1 is 2, and x squared times x squared is x to the power of 4. Now we have 2x squared multiplied by 2x. So we have 2 times 2, which is 4, x squared times x, which is x cubed. Now we're going to do 2x squared multiplied by 3. 2 times 3 is equal to 6. And we have our x squared. Now let's start with this guy over here. 3x multiplied by x squared is going to give us 3x cubed. 3x times 2x is going to give us 6x squared. Again, because we have 3 times 2, which is 6, and x times x, which is x squared. Now we have 3x times 3, which is going to be 3 times 3, which is 9, and our x from this x over here. Now we're going to go with our last term outside the brackets. 1 times x squared is going to just be x squared. 1 times 2x is 2x, and 1 times 3 is 3. Now let's see if we have any like terms that we can add together. We only have 1 x to the power of 4, so that's going to stay 2x to the power of 4. We have a 4x cubed, a 3x cubed, so we can add those together. 4 plus 3 is 7. So we have plus 7x cubed. Now we have 6x squared, another 6x squared, and an x squared. So 6 plus 6 is 12, plus 1 is 13. So we have 13x squared. We can cross out our 6, our other 6, and our 1 here. And now we have 9x plus 2x, so that is going to be 11x. And then we have our 3 by itself. And again, we can double check to make sure that these are in the correct order. So we have the highest degree, our leading term first, then our second highest, third highest, and so on. So this is our final answer. So you can use this exact same method and exact same logic whenever you're multiplying monomials, binomials, and trinomials together. You're just going to go one by one and multiply every single term outside of the brackets by every single term inside of the brackets, and at the end you can just simplify to make sure when you have any common terms that you add them together, and you can give your final answer in order of decreasing degree.